Scientific notation. We're going to use scientific notation in our class because oftentimes scientific type numbers are very, very large or very, very small. And when they become so large, it's hard to write them down, or it's tedious, or you have accuracy issues. For example, you can see how far Neptune is away from Earth. There are a lot of zeros there and a lot of place values to keep track of. And the same thing with the mass of hydrogen. You have to write a lot of zeros before you even start writing non-zero numbers. So that takes a long time to write, and it's easy to forget a zero and then your number is incorrect. So to use scientific notation, it's based off of powers of 10. 10 squared is equal to 100. 10 to the 0 is equal to 1. 10 to the negative 1 is equal to 0.1. You can see that there. And it's a system of a coefficient times a power of 10 with an exponent that's either positive or negative. And if we apply that scientific notation system to the distance of Neptune and the mass of hydrogen, those numbers become much more manageable, and it's much less likely that you're going to make a mistake. So if we're going to switch numbers into scientific notation, we're going to take our standard notation, that's how we're used to writing numbers, and we're going to switch it into scientific notation by doing a couple things. We want to move the decimal place so there's only one place value to the left of the decimal, and that number to the left of the decimal is between 1 and 9, so it can't be a 0. We're going to count the number of place values that we moved that decimal, and that's going to become our exponent, the number of place values we move the decimal. And then if it's going to be negative or positive is based on the direction that that decimal moves. I'll show you a couple problems right away. Write each number in scientific notation. So I'm going to take my decimal right here. I'm just going to draw a decimal so that the decimal is placed such that to the left of it there's only one non-zero number. So in this case, the 7. I couldn't put it between the 8 and the 6 because then there would be 2 place values when we want 1 place value. So I know I'm going to write down 7.86, and you can go ahead and do that. That's our first step. We know it's going to be times 10. And then we're going to decide how many place values we move this. So when you're moving a lot of place values, sometimes I just group it in threes because that's pretty easy to see. There's 3, there's 6, one more makes 7. So we know it's to a power of 10, but we have to decide, is it going to be a positive 10 or a negative 10? I like to just reason this out. I like to think, is 10 to the 7 a big number, or is 10 to the 7 a small number? And if you're not sure, you can just put in your calculator. You can think 10 squared is 100. That's a pretty big number. So 10 to the 7th must be a big number. 7.86 times 10 to the positive 7 would be a big number. Is this big or is this small? Well, that looks pretty small to me with all those zeros. So that means I need to multiply by a small number instead of by a big number. So a reasonable size number times a small number makes a small number. Over here, number 2, my decimal needs to be so there's only one place value. So I know I can write down 3.94. Then I know it's going to be a times 10, and I can see how many place values I moved that decimal. The imaginary decimal was sitting behind the 0, so I moved it 1, 2, 3 spots. So I know it's going to be 10 to the 3rd. A reasonable size number times positive 3, that's a big. So reasonable number times big number makes a big number, which is what I need it to be, so it's going to be positive 3. It's worth noting, if you're an honors chem or regular chem, your answer needs to contain the same number of sig figs as the original problem. So 7.86 has 3 sig figs, this has 3 sig figs. Number 2, there's a 0 as a placeholder, but right now that 0 is not significant. There's 3 sig figs. So I can't put an extra 0 behind that 4, because that would make there be 4 sig figs. This problem number 3, 4.7, there's only one place value to the left of the decimal. That means we already have the correct notation. And if it's already correct, I'm not moving my decimal. So this is actually 10 to the 0, which is the same as 1. So 4.7 times 1 equals, of course, 4.7. Number 4, between the 1 and the 2, 1.26, that's 3 sig figs, just like my initial. We know it's times 10. We know it's going to be, there's 3 spots, 3 more, 6. Now, positive or negative, a reasonable sized number times a big number makes a big number. Positive is big. Switching back to our conversation, what if we want to go into standard notation? We have a number that's in scientific, we need to go the other way. So we're going to look at our exponent and decide is it a positive exponent or a negative exponent, and we're going to move our decimal in relation to that. If it's a positive exponent, we're multiplying by a big number, we need to move our decimal right. If we're multiplying by a negative exponent, we're multiplying by a small number, we need to move the decimal left. The number of place values that we move that decimal are equal to the exponent. For big numbers, remember not to add a physical decimal point because that'll make more sig figs most likely than what you need. And then for exponent of 0, we're not going to do anything. It's telling you to move 0 times. Some problems here. 6.17, we're going to move 3 places, but which direction? 10 to the third is a big number. If you need to plug this in your calculator, you always can. 10 to the third is a big number, so I need to make a big number. So my decimal needs to go right to make this number bigger. It needs to go right 3 places. 1, 2, 3. I'm going to fill that empty place value with a 0. Now notice I'm not drawing the decimal point at the end because that would make more sig figs. I need to move my decimal place 4 places, and since 10 to the positive 4 is big, my decimal needs to go to the right. Right now, my imaginary decimal is right here. I need to do 4 loops, and each loop gets a 0. I need to add 4 zeros. Number 7, again, it's a positive number, so this is a big multiplier. My number needs to go to the right. It needs to go to the right 6 spots because that's the exponent. So 4 more loops, which means 4 zeros, 7, 3, 1, 1 0, 2 zeros, 3 zeros, 4 zeros. This time it's 10 to the negative 8, which means I'm multiplying by a small number, which means I need to make 5.4 smaller by moving the decimal to the left 8 times. So here's 1 spot. That means I need to put 7 loops, which is going to be 7 zeros. 1, 2, 3, 4, 5, 6, 7. And now I need to actually include that decimal. 4, 5, 6, 7, then a 5, 4. And I prefer to write a number in the front. Again, each time we write these numbers, we're making sure the sig figs stay constant. So that's switching into and out of standard and scientific notation. But we're also going to need to do math with scientific notation, and it's important to be able to use the correct key on your calculator and know how to use your specific calculator. So on the left here we have a Texas Instrument calculator, which normally uses the EE key. Many of you have this calculator. On Casio, many of them are EXP keys. And of course there are some exceptions which you might just need some specific help. But you need to know where your key happens to be. So in actuality, on this calculator, right above the 7 is a scientific notation key, which is my EE key. But you'll notice that the text that's printed above that EE key right here is blue. So in order to turn on the blue letters, the EE, I need to hit the second key, which also happens to be blue. So I have to hit second key, then the x to the minus 1 key to turn on scientific notation. On this Casio, and many of you have a calculator that looks something like this. It's a Casio. Oftentimes these keys are just EXP, and you'll just strike that key since it's written on the main key, it's not above. We won't need to turn on the second function or the shift function in this case. So problem number 9 that I have on my example is a multiplication problem. So I need to be able to put this number in here. I'm going to turn on my calculator. I'm going to type in 6. And then the times 10 portion here is going to be represented by me using the EE key, my scientific notation key. So I'm going to hit the second key, EE. Now it's weird because this says EE right here, but the calculator only says E. That's okay. That represents the times 10, so then I can just do 6. Then since this is multiplying, I can hit multiply, or I could just put these both in parentheses as it says right here. 4, second key, EE, to represent the times 10, and I need to do -1. -1 was right here. Make sure you use the negative key instead of the minus key. I'm going to hit enter, and then this is a really big number, so I can only have one place value to the left, 2.4. We know it's going to be times 10 to the however many place values we need to move this. Here's 3, here's 6. This is going to be a 6, not positive or negative. This is big, so I need to multiply by a big. Likewise, in problem number 10, this one is going to be a division problem, but we're going to want to use our scientific notation keys to do this. So I'm going to type in my coefficient, 4.11, turn on my EE key, which only writes down E, and this is a +5 right there, so we omit this part when we plug it in. Divide by, this time, 8.65, second key, E, -5. Again, that was -5. If I hit enter, again, this is a really big number, 475 sig figs. For if you're in honors or regular chem, we have 3 here, we have 3 here, so 475 times 10 to the something here. We know my number can only have one place value after the decimal, so I'm going to count place values. There's 3, there's 6, and then there's 9, so this is 9. That was a lot of counting there. You can use your calculator to help you even more. We want to turn on the scientific function right there, psi. Second, psi. We want the scientific, so I'm going to scroll, hit enter right there, and now the number's told you in scientific notation. If you want to turn that off, same keystrokes, second, psi, go back to flow, use your scroll button, hit enter, and it toggles back. It's worth noting that I need to go back to this problem. Remember about sig figs. There's 1 sig fig, there's 1 sig fig. So if you're writing this in sig figs, 2 times 10 is 6 would be appropriate.